Morning, folks.
Good morning.
We'll give everyone a minute and then we'll get started. Maybe a couple of minutes.
David, I have a quick question for you.
Okay.
I may not actually stay for the full meeting here. Do you remember we were going to create the HBM4 part model?
Okay.
So when we initially created it, it had the complex pattern stuff, and it was suggested that maybe we should make a version of the part model and not include all the complex patterns, but keep the patterns at a flat structure, just to get people used to the concept of the part model, and then at a later stage, revert back to the more complex structure to reduce the file size. So at a simpler level, flatten everything down into simply a list of XY coordinates in a random array, and connect that to the electrical properties, and then flattened it without having all of the nested hierarchy patterns. Is that of benefit to you? And would you use it in your design?
Can you can you repeat that, Michael?
Putting the HBM4 into the part model, when we initially created, we created it with the hierarchical nested patterns within patterns, etc. And that significantly reduced the size of the file down to less than, I think, 1 megabyte or so. But it's a more complicated structure to understand. And one of the suggestions was, why don't we just simply flatten the structure? Don't have the nested hierarchy patterns, but create the part model with a flattened structure and then list out all of the XY coordinates. If we go down that path, that's something that you can use then in your design. I don't want to end up doing it if it's not going to be consumed by in one of your designs that you're planning on OCP.
Yeah, I think let me. I think it's a good idea to have something simpler, right? That doesn't go crazy on all the possibilities. On the other hand, I'm not entirely sure how simple do we want to go, right? Fully flat is one way to do it. The other thing, what I was thinking is just one level of hierarchy, right? If you, for example, all the of the 32 channels, right? That could be, each channel could be one flat hierarchy, and then instantiated 32 times. The benefit I see in that is it shows the idea of those of the hierarchy in the bumps, right?
All right. So try to minimize the number of hierarchies. Okay, we could do.
Right.
We could aim to do that. Yeah. So
basically, something simple for everybody to grasp the concept, right, and understand what's going on, and then, right, adding more hierarchies is more of the same, right?
Yeah, it's more of the same. It's just duplication.
So exactly. So this is kind of like the hello world where we have one hierarchy and kind of shows this how this gets used.
All right. Now, if we go down and do this, I've got a lot of part models that I need to get created for various standards. If we do this, is it going to be consumed in your design?
We can demonstrate the consumption in the design flow. Yes.
You can. Okay.
Yeah.
When do you, the last question then, when do you need to have it?
Probably not. It's not a high urgency. Right now, we are kind of looking at. I mean, from design point of view, we are looking at the power stuff. Power stuff in that design. So, what is your timeline looking like? It definitely not urgent on our side.
All right. So Q2 of next year, would that be fine? Or is that too late?
Okay, let me ask you this. Is there anything that we can get sooner? The reason I say that is Chiplet Summit is coming up in February. So
Okay, so
maybe if we can demonstrate it by then and talk about it, I think that's going to be a good thing.
Okay,
So Michael,
all right.
what is the compression ratio from flat versus what you currently have?
I think it was the last analysis we did was like 7% in size.
7%. So 93.
7. Yeah,
So 93% reduction.
yeah, something like that. Yeah.
Mhm. Again, these are not huge files. A megabyte is not a big deal.
Yeah, well,
Actually, Michael,
at this stage, they're not. But remember, we were building this so that. Sorry, go ahead, David.
how about the actually, let me ask you. I think JEDEC was planning to release the part model for HBM anyway, right? Would that be the fully complex
No,
one?
that is what I'm stalling on, right? I have to finish that, and I've got 13 more part models that JEDEC wants to get done, and that one alone will take a lot of time to do. And so what we are discovering is as we're doing the other standards in part model that we are needing to make small changes and here and there on the schema. Like, for example, we just finished a process of digitally signing off on the part models, and we have discovered a bug in the schema, so we need to fix that. I'm trying to get that bug in the schema fixed by December, and so that I can digitally sign off the part model when we first launch it. But if we don't get it fixed in time, then we will go ahead and release the part models onto the JEDEC website without the digital sign-off and come back and re-release it in an upgrade with the digital sign-off in the new year. So right now I'm focusing on all the simpler part models, which are just package-related data for the package outline. And I've just put the HBM4 on hold. So because I just don't have the bandwidth to do all of them together.
Yeah. I guess the question is, do we want to talk about this at the Chiplet Summit in February?
You do. All right.
Right. If we want, I kind of think it would be a good idea to show this off, at least show something off. That is going to be pretty interesting, right? And how do we make that happen?
Well, I just have to reprioritize what I do on the other JEDEC standards, try and get out of those and focus on the HBM4. Because I got the approval and everything to proceed with sending it to the ballot process. So that's not an issue, right?
Okay.
It's just a matter of getting it ready to publish.
Maybe we can we do
So-
a kick? Can we do parallel work? Right. If we want to, do you think? Okay, let me ask you this: do you think by early next year, kind of like January, February, you will have the final HBM model and I mean from JEDEC side and publicly announce it?
Yeah, I can. Yeah, I can do that.
Okay. Can we do then work in parallel where we kind of work on the flow to ingest this and such that we align and then come Chiplet Summit, JEDEC says, hey, look at this. We are releasing the JEP30 models, and then OCP says, look at us, right? We can ingest it, and here's a workflow that we have
Okay,
have
we can do
demonstrated.
that, but then how soon do you need the model in order to start the work on ingesting it?
Uh,
Can
early
can you wait
December.
to can you wait to January, or do you need it in December?
You're thinking of making small changes to
Well,
the model, or
no, I just need to finish it. And if I need to finish it by December, I have to drop a lot of other things.
okay. Um,
Oh, wait, like
yeah, okay.
here's a real example.
Yeah, if you drop it to us in the first week of January, I think that would work, right? There's so many holidays by the end of the year that probably first week of January is better option.
Okay, that's fair enough then. That's what I wanted to know.
Yeah,
Okay, very good.
yeah. Okay, we have new participants. I see M3 and 5 RW. Hello.
No, that's me.
Oh,
That's-
okay. Okay. All right. Okay. I see you also have Singman. We had a quick meeting yesterday. So Singman, do you want to update the team where you are with the power stuff? I don't think the team is aware of all the side discussion we've had. Maybe you can give the team a quick overview and share some of the results which you have.
Yeah, sure, of course. Do you see my screen? Yeah. So we made demo design with 4 CPU and 4 HBM. So the next step is, as you may remember, analyzing power integrity. So for the power integrity simulation, we first need IVR spice model. And on the chiplet side, we need CPM, which is chip power modem. That includes PDN, PDN prosthetics, and current waveform. And we also need, most importantly, the package parasitics, like in S parameter format or other GC format. So we just made an initial simulation setting. So first of all, we found the IVR spice model from academia. So there's a paper that generates the IVR GDS automatically with the operating frequency of 125 megahertz. And on the for the chip CPM model, I've already made for I've already made a CPM model for one open Python tile. So I just connect multiple. So since we have 20 cores in our CPU design, I just connect 20 CPM model in parallel.
Did you manually create the CPM model? Or did you
I
tool
used
it?
I used ANSYS Redhawk to generate the CPM.
I'm sorry, you used what?
ANSYS Redhawk.
Okay.
Yeah, and so for the interposer PDN, before we design the actual PDN in our demo design, I just brought some reasonable values, the RLGC values here. So inductance 136, capacitance 1.6 nanofemto, and G for resistance, yeah, 18 mega ohm and 55 ohm. So we created this simulation setting, initial simulation setting, and also we just assume enough, not enough, but just reasonable decay amount in the interposer network. So this is the simulation result. Yeah, so we were able to see the waveform and the impact of CPM, so like triplet power and interposer PDN on the power integrity. So yeah, this is what we've done this week, and the next step will be actually designing the PDN on our demo design and see how these waveform changes. Yeah. That's all for this week.
Yeah. Yeah, basically, if I can summarize at high level, the idea that we are proceeding with is that we basically start with a lump model, right? Get all the components in one simulation, right? Get the CPM, get the RLGC for package, get some IVR, and basically have an initial simulation setup so that we can start looking at values and then progress on identifying and refining the different pieces, right? And basically keep on upgrading this model with the more recent data. Kind of have a feedback loop, which kind of normally what happens. So yeah, as Sigmund mentioned, he picked up the IVR. Typically, it's high switching frequency. Next we'll look at the on refining on the package PDN or the RLGC model of the package. Probably do a first level power insertion and see what the values are. We also talked about upgrading the CPM model a little bit in the sense that this one is a steady state transient, meaning continuous activity at the same levels. Probably it will be a good idea to look at changes in activity and see what happens to the PDN. So right, that was one upgrade of the CPM models that we'll need to do.
So that would be, so can a CPM, would that be multiple CPM models or would be like a piecewise linear CPM?
The CPM model by itself is like a spice net list, right? It's
Right.
basically, RLCs with current waveform.
Right.
So we'll see. That's one interesting.
So the voltage recurrent source could be an equation, you're saying?
No, it's actually it's PWL, right?
It is a
actual
PWL. Okay.
Yeah. It's PWL, but it's basically from one simulation run with one set of activity factors.
Right.
The second set of activity factors is going to be a different CPM. So we're going to have to play a little bit with that setup and see how we can organize it and what would be a reasonable
I see.
assumption for changes in activity factors.
All right. So you're not running a timing simulation, or you're not running patterns, right?
Yeah, it's not running
Because we
patterns.
could.
No.
I mean, we can with this design run software, right? Is that a flow, or do you have to create the piecewise linear with these discrete activity?
That is a flow in the sense that in terms of, okay, so there's two sides to this, right? One is being able to consume the CPM and run PDN simulations. Right. And typically this early in the flow, this is kind of the level of quality of PWS you would get, right?
Okay.
They're just
Yeah.
approximations.
Yeah.
So we'll work with these for now, right? Then at some point we're going to have to go back and run simulations on the course and see the actual waveforms out of that. And even with that, right, we're still going to have to play with the waveforms because you cannot expect, right? We're going to run one core, one simulation. You cannot expect all the cores to be doing the same thing all at the same time, right? So we're going to have to play with that simulation and see how we can have different activities across the course and see what happens, right? Kind of make it more interesting.
So so you'd have to create a contrived set of, in this case, software. You run software to run and create different interesting power activities.
Yes.
Yeah.
And the way I would define interesting is we know what one core does, right? The question is we have 4 different chiplets with 20 cores each, right?
Right.
What is the worst activity that would stress the power network, right? Is it all active, or is it different chiplets going in and out of different states, right? There may be different answers for the power side of things and for the ground side of things, which is common across everybody, right?
So yeah, I would think when all of them are running at the highest frequency, that would give you the largest noise and higher drop. But are you looking at running these at maybe different frequencies where you would start getting harmonics and stuff? Or is it just the parasitics where you're going to get time skews anyhow? And
we can do the different frequencies as well, and keep in mind that when activity stops, the ground will bounce, right?
Right.
Because that energy goes into ground. So maybe and ground is common for all the chiplets. So
so when you fire one up or off, you have these discontinuities, which could be interesting.
Right.
Yeah. Okay.
So, but we need to get to a same setup, right? First, right? Start with the lump model, improve it, make it bigger to include all the chiplets, HBMs, IOs, stuff like that, and then see what happens.
So does Red Hawk, can that can you give it different activity factors and it'll create that piecewise linear, or do you have to kind of stitch those together?
I need to figure out how to do that.
Okay.
Yeah.
Yeah, worst case, we'll stitch them together.
Right.
And even that, I suspect we'll have to post-process those CPMs anyway, right?
Yeah.
If we start looking at scaling for frequency or things like that, right? How would that work? So, yeah,
Yeah, the problem is if you run real patterns, you get very long simulation runs, and
yeah.
tools don't. Yeah, those kind of tools running on a full net list, you can't run milliseconds or seconds of simulation time. That's the problem.
Yeah.
Okay.
Yep. So that's where we are with this.
Mm-hmm.
We'll see where we take it. Probably it would be good when we upgrade this model with more data on the package and IVR side to one of the things we talked is add the board side of things, right? The conversion
So the
from
stuff on the top is the board.
that's the package. Right now we have the
Oh, that's
package
the
only,
package. Okay. All right.
right?
All right.
Kind
And
of extend it all the way out to the board and see how that looks.
so the circuit on the bottom is for what?
This is just IVR only. So just to see the waveform when it's IVR only.
What is IPR? Sorry.
Integrated voltage regulator. So I just compare
So
to-
integrated in
so,
the package. Yeah.
yeah.
Okay.
one with the IVR only and the other with IVR plus interposer lumped model and CPM.
Ah,
So the,
okay.
yeah. So the
Okay.
right one, yeah. I just compare it to.
This would be the discrete chiplet that would go on the interposer, or is the IVR?
Yeah, that's the intent. And our next step is to update the floor plan, put the chiplet on the bottom, give it all the power nets, and I'll hand that off to Singmin for quick layout.
Put the IVR on the bottom of the.
Yes, on the bottom of the substrate.
Substrate. Okay.
Yes.
So do we have an interposer and a substrate?
No, sorry.
Bottom side
The-
of the glass interposer, right?
Yeah, on the bottom
yeah.
side of the glass
Oh, the
interposer.
bottom side of the glass. Okay.
Yeah.
That's right. This is a glass. Okay.
Yeah.
Okay.
Any feedback about this setup from folks on the call?
Let's look at it. So these are all discrete components that will go on the bottom side as well. All the stuff on the top.
Yeah.
6. PW. What is that? PWM underscore R and the SPD dynamic switch.
That's the IVR.
Yeah, this is IVR. Yeah. This whole circuit is
Oh, I see.
IVR,
Okay.
IVR circuit. Yeah.
Got it.
Yeah.
Okay. Yeah, I would put a box around that and make it. Okay. So it's just that, and you have some passive components on the outside.
Yeah.
Yeah.
That is, so is that 200 nanofarad cap in the
In the IVR, yeah. For the IVR, yeah. For
Yeah.
IVR,
okay.
25 nanohenry and 200
So is
nanohenry.
this kind of a mock-up of a real IVR?
Yeah, the source is from this paper.
Oh, can you
So-
throw that in the chat? That's cool.
Oh yeah, of course. Actually, I can share all the references after this meeting to all.
Yeah.
Yeah, that would be awesome.
Yeah,
just-
this actually fairly it's a realistic IVR, right? In the sense that it actually has a it has a circuit, it has the GDS, it has everything extracted.
So this is something Georgia Tech, somebody developed this?
Yeah, so this
Cool.
automatic GDS generator is from Professor Cyber Mukapati.
Can we get GDS?
Yeah, I think so.
Well,
yeah.
I guess it doesn't really matter, but I mean,
Yeah.
we could make a chiplet out of it, but
But at least we have the bump map of IVR and
for the analysis, I mean, that's not interesting. It's really the model, which is you'd need
Yeah.
anyhow. So, okay.
yeah.
Got it. Very interesting.
I'll share these references after this.
Nice.
Yeah.
Yeah, I like it. I mean, the other thing that I see people doing is they're embedding them in the substrates.
Uh,
And so the interposer, this is just the simple RDL topside and TSVs or TGVs.
Yeah, yeah. The layer configuration is, so we just use the one side RDL or double side and
Yeah.
glass core and TGB.
Yeah, because I know the stuff that Absolic's doing is much more interesting, but they have embedded planes inside the substrate, embedded structures. They have RDL top side, bottom side, and fan out. So overkill for what we're trying to do here, but
yeah. I think, right, I think even putting the IVR on the bottom and demonstrate a working flow is
it's in the package, right? Yeah.
yeah. It's on the package, and also it's on the bottom of the package too. Show the vertical power, which is hot these days. Yeah, it could.
It's coming from the bottom anyhow, right? So
Yeah.
how does that get? I mean, would this thing be sitting on the substrate?
We'll put it on. We'll
Glass
put it.
interposer. How do you get your pins to the bottom side?
Um.
And is it just traditional BGA?
Yeah. We'll. So we haven't really put anything below the glass at this point,
Mm-hmm.
right? Because that's not too interesting to do. So we kind of imagine that below the glass things will somehow get solved. And really here demonstration is add the power, basically exercise the power planning workflow.
Mm-hmm.
Right. So yeah, we'll have a gap here or there, but I don't think that's a showstopper.
Yeah. Right. But and so Sigmund, I think you know a little bit more about these glass interposers. Do they generally sit on the substrate?
Sorry, I didn't fully understand your question.
Do these glass interposers generally sit on an organic BGA substrate?
Yeah, I think so. Yeah.
Yeah.
Yeah, they use
Okay.
the same. Yeah.
So essentially the way I would see this is if you built a substrate, that VRM would just essentially be embedded into the top side of that substrate and then just connect directly to the power network.
Yeah. You can also embed chiplets in the glass core.
Yeah, or in the core. You could either put it in the substrate or the core. Yeah, well, you'd probably. Okay, never mind. I'm thinking real world. This is a demo.
Yep.
Okay.
Actually, I participated in work that compares that designs the glass 3D, which embeds memory chiplet inside the glass substrate and put the logic or CPU on the top side and compare the PPA. So yeah, I can share that paper if you're interested in.
Sure.
Yeah.
And how much current can these IVRs provide?
Which current?
What is this one? Does it say?
Let me find it on the paper.
You've got what one? Yeah, I'm just curious. Because I think generally you would put a bunch of these right underneath the chiplets, right?
Yeah.
Yeah, they're probably smaller than the chiplets, so you might even put multiple right under, embed it. Actually, they're back several years ago, we were on a project where we used a VRM that actually was embedded in the chip. So it was a piece of IP that you would set right on the top layer and feed the power right directly from the top side. But the
Was
So-
that one LDO or
what's that?
was that an LDO or buck converter?
I think it was an LDR.
Yeah, okay.
So
No,
the
no, I
original,
mean,
yeah, we were
yeah.
doing this for a large company, and the original vice president recommended that, and the CTO thought it was too risky, so we ended up doing it external. But the original plan, there are companies that have SOCIP VRMs where you put it right on the top side of the chip and you feed the power from the top side. It's kind of cool.
Okay.
But now, everyone's looking at doing bottom side power through the back side of the die.
Yeah.
All right.
I just found the current that can IVR one IVR derives is
Yeah.
1500. Yeah.
How much?
1500 mega.
15.
I'm sorry, milliampere. Yeah.
So 1.5 amps.
Yeah, 1.5
Wow.
amp. Yeah.
Okay.
That's pretty good.
Yeah, that's
Interesting.
So 3.6 volts. Oh, what's the output voltage? 1 volt.
Yeah, 1 volt. Yeah.
Okay. How much power does our chiplet, well, our design, do we know that? Have we run power analysis yet?
Oh, power. Around 10 watt. Yeah.
10 watts.
Yeah.
Most of that's core. I guess it's probably all core, right?
Yeah. 10 watt in 10 millimeter by 10 millimeter footprint.
So 10 watts. Okay. Which means you need 10 amps, right? At 1 volt.
yeah. Yeah.
So don't you need like 6 or 7 of these?
Yeah, I think we probably need more
Yeah.
IVR. Yeah, you're right.
Yeah.
I
Yeah.
think that's why our current IVR requires a huge decaf if you
Yeah.
use one IVR. Yeah.
Well, how big is the IVR?
IVR cell is
Not that it matters. We can make it any size we want, but just
yeah
for sanity's sake, how much is the one in the white paper? What's the size?
I can let you know.
And then how big is the chip? How big are our chiplets?
Our chiplet is 10 millimeter by 10 millimeter
10
and
by 10.
yeah,
Okay.
and IVR. Oh yeah, it's 0.48 by 1.2 millimeter. So it's much smaller than the chiplet.
Okay. So we could put them right under the chiplets.
Yeah.
Put a couple of them. Well, yeah. I think we're gonna need to do that, right? Otherwise, we're gonna see a lot of droop.
You're interested.
Either that, or since this is a schematic, it's easy just to provide 10 amps, right? But for the demo. But then you
Yeah,
gotta
we'll,
you gotta
yeah,
run
we'll,
all the steps. I think I would just go for it. Why not put 4 of these in?
yeah, Tony, we really haven't. So Signet just created this. Right, we haven't really looked at sizing these correctly and so on, right? This is just the initial
Right.
setup, right? That's exactly the reason I wanted to have this initial setup so that we can start looking at
Right.
these things, right?
So what is the status of everything else? The interposer and the chiplets layout?
Yeah, chiplet, as I said, so one chip CPU chiplet is 10 millimeter by 10 millimeter. And
We have a layout for that?
yeah, of course. Yeah, we
Okay.
have chiplet layout.
Yeah. And how about the
And
interposer?
interposer, I think it was
Interposer is interposer.
Do we have a layout for the interposer?
yeah, but the PDN is not designed yet, but
Okay.
it is designed the CPU to CPU signal routing and the part of CPU to HBM routing.
Okay.
So the next step is to design.
Next step is the
PDN.
PDN, and I guess the plan would be just go straight with this VRM and have the PDN hook everything up to the PDN on the bottom side.
Yeah.
Yep.
Cool. Actually, it'll be easier to route if you have 4 PDNs, one under each chiplet, right?
Yeah, when we'll yes, exactly. We'll have under each chiplet. Actually, we have to have it under the chiplet, right? We cannot put it on the
Right.
side because we have all the other chiplets on the side. And then we'll have to add IVRs under the HBMs as well, right? To provide the different supplies to the
Yep.
HBMs, and then IVRs under the IO chiplets. So it's gonna look pretty interesting already, I
And
think.
what about the UCIe? Do they need a separate supply? They probably do, right? An analog supply.
Yes, it does need separate power supply, so we need IVR for that as well. So this schematic
What you
that's
could probably do, since you have 4 chiplets. But the HBMs. What do you have the overall floor plan? I forget where the HBMs are.
yeah, the HBMs are left and right. IOs are top and bottom.
Okay, so you have UCIEs stitching all of the 4 chiplets together, right?
Yes.
So you could probably put one right in the center and feed all those.
I think the UCA power is a little bit more than that to allow for just a single IVR, or we're gonna have to have multiple IVRs as well.
So you would need one because you have what, 1, 2, 3, 4, 5, 6. There's 8 interfaces, right?
Yes. Yep.
Well, 12 if you count the externals.
Yeah.
Yeah. And then the HBMs, you need a VRM, and they have an analog supply as well. So all the die-to-die interfaces need a supply. I think you could probably.
Yeah, we should.
I don't think they draw that much power, so might be able to share some of those. But they're small enough, you could probably put them in the corner, right? One in each corner.
Yeah.
Okay. Or center or something. Yeah, I would say in the floor plan, we should probably start adding those in the floor plan and figure out where they're going to fit.
Yep. That's exactly what Marcin mentioned, the bump map. That's The
Yep.
next immediate task is get that IVR set up and place it somewhere and see how it looks. Right. We'll size it, size the number of IVRs, add them to the floor plan, and see how things look.
Right. So I guess we would have C4 bumps on the VRM.
Yep.
Yep. And all the power to all the silicon up top is coming through glass interposers, right?
Say it again. Which power?
All the power, right?
Yeah, all the power is going to come for all the power for the chiplets is going to come from the
Through
bottom.
those interposers.
through the interposer.
TSVs, I'm sorry, the TGVs.
Yes.
Glass
Yep.
interposers, yeah.
Yep. And then the IVR input power is going to come from the bottom.
Right.
But yeah. You can see the floor plan, and we'll just put them on the bottom of this.
Are those HBM4s? Is that what we decided to go with?
Yes. We had to go. We cannot go with anything else.
Are those the actual sizes of HBMs?
Yes.
They're
Well,
10 as well, or?
I'm sorry. They're actually the chiplets are 11 by 11, and the HBMs are 11 by 14. That's the HBM4 standard.
Okay, this is not to scale then.
Why do you say it's not to scale?
Well, from this diagram, is it?
Yeah, it is.
Oh, it is. Okay.
Yeah.
Oh, okay. So the height, the way they're placed, is 11, and the width is 14 for the HBM.
Yes. Yep.
Okay. Yeah, it's hard to tell at this resolution. They look the same, but okay.
Yeah, it's just
They're a little bit wider.
it's
Yeah.
close enough. Yeah, they're just a tiny bit bigger.
All right. Great job.
Yeah.
What we think we'll have this ready for the Chiplet conference?
Chiplet Summit. Yeah, we'll see how much we have ready. Right. We'll try to make progress. We'll see where we end up.
So have we registered for that for OCP?
What do you mean? I was talking about the Chiplet Summit, not the Global Summit.
Yeah, that's what I'm talking. Has the CDX group, have you guys registered for the Chiplet Summit?
Not yet. We are setting up right now. We are looking at the booths. At least, right. My company is looking at the booths. But yeah, we'll need to do a submission. You're right, and we'll probably do one. We should do one and see what we can accomplish.
Siemens will have a booth. Would you be interested?
Is Siemens?
I'd have to talk to them. If you're interested, I could talk. See if they'd be open. I don't know if we plan on doing any booths, but
Yeah.
as they're open, I could ask.
Yeah, I think CDX will benefit, and Sigmund will benefit from some exposure from the work he's doing. So if Siemens can help, that would be awesome.
Okay. All right. I'll take an action to talk to the powers that be.
Okay. Yep, and if we get JEP 30 working, that may be interesting to talk about as well.
We are using JEP 30, right? For the dies, right?
Not yet. We haven't really started looking to generate the models.
Okay.
We'll probably do that a little bit later.
Right. Okay.
Yep.
Very good.
So that's all from our side for today. Any thoughts, comments, any suggestions, feedback?
That's excellent. I'm impressed. I missed several meetings where you brought all this VRM stuff in there, so it's pretty cool.
Yeah.
And you
I
driving?
am,
Are you driving this with UPF? The PDN?
UPF. No, we didn't. I didn't make them. Yeah.
Because
Yeah.
Jeff is still on. Yeah, we have Jeff is actually working on the UPF flow for I3D or XSI, whatever you want to call it. So if we want to generate the net list with the UPF, we can test that out with our flow that we're working on.
That appears interesting. Yeah.
So Jeff, would you be willing to work with Segment on that? Maybe get you guys can work together.
Of course not, Tony. Yeah, of course. Any help and
we've been
suggestions?
looking for an example, so this would be perfect, right?
Yeah, there's a lot going on with power. So
Yeah. So, I3D officially supports UPF, but we're checking it out to see how to use it, and found a few issues here or there, but this would be a good pipe cleaner.
Yeah, maybe you guys can, why don't you sync up with Singer and see what version of the software is needed for this? And then we can deliver the UPF for this and see if that flow works.
Yeah, I mean, do you have the latest update of I3D segment? You're using it as a Georgia Tech?
Ice Rigging?
Yeah.
What is Ice Rigging?
I3D is the new name for XSI.
Oh, really? Oh.
Yeah.
Yeah. I don't think we have, but I can ask to our
Yeah, find
IT
out.
team.
If you don't have the latest, we can
Mm.
get you an update, because
Oh yeah, of course. Yeah.
it's got a lot of new features in there that and UPF is one of them that we do want to test out. So Jeff has been we're putting together a very simple test case, and so far it's good, but it's a very simplistic. All we have is one power domain, so it's it's totally boring, right? It's not really stressing anything. But if we had different power domains for the HBMs and the PIs, that would be a much better test case to make sure it works for doing the entire PDN.
Yeah, I agree. Yeah, I'll check whether the tool is available or not. Yeah, that'll be very interesting if you can do that. Yeah.
Okay. All right. So Jeff, maybe you could set up a separate call with Sigmund and I guess Kevin, if you don't have the latest software, I can ask Kevin to work with you guys to get the latest and greatest. So what professor are you working with?
Oh, I'm under Dr. Wuhan at Fakir.
Okay. Yeah, I actually met him at the in GMAN a couple weeks ago. So we did agree we're going to get together and
Oh,
start working on some stuff.
oh, yeah. It was.
Okay.
I have a quick question for David. Do you remember that meeting we had on the test modes of operations of the part model? Did that address all your needs on the DFT for test in the part model, or do you still want to have additional meetings on that?
Yeah, let's review one last time before we call it done.
Okay.
I don't. The reason I say that, I don't have immediate feeling that we 100% finished everything. So it would be good to, and it was some time back. I think it would be good to sync up, cover what was needed, see if it's there, and if it's there, we are done.
Well, do you want to do that in the context of the JEDIC meeting or in the context of a meeting like this?
I probably it would be better in the context of JEDIC meeting.
All right, so one of the Thursday morning meetings, we can
Yeah.
allocate to that.
Yeah.
All right. Okay. Okay. Maybe
all right.
maybe the 20th, because I will be out on the 13th.
Yeah, sounds good. Yeah,
Okay.
we'll do that.
All right,
All right.
and David, if there's others that you want to involve in that meeting to attend to that, just drop me a line and I'll send them the invite.
Okay, sounds good.
All right.
All right, everyone. I think that's it for today. Happy Friday.
Yeah.
One thing you may have noticed is I changed the meetings to bi-weekly to give us a little bit more breathing room between meetings to accomplish stuff instead of having meetings every week. So I think that would be good for everybody. So I'll talk to you. We'll talk about the demo design again in 2 weeks.
Okay. Okay.
All right,
So
everyone.
if we need like a short technical meeting, say between Jeff and Sigmund, maybe we could do it on the alternate week or something.
That's right.
Yeah.
Or yeah, just feel free to set up ad hoc meetings.
Yeah.
Yeah.
That's good.
All
All
right.
right.
Happy
So-
Friday.
Very good.
Yeah.
Happy Friday.
Different.
Bye-bye.
Bye.
Thank you.
Tony, you still there?